Hi, my name is Dana Martins, and this is my presentation, Virtually Usable, a presentation that looks at evaluating usability for virtual reality applications. This presentation is paired with a longer literature review that I did for my Design for Usability class in the spring of 2016 at Parsons, the New School for Design. First, a little bit about me. I've had a lot of different careers throughout my life before coming to Parsons, mostly within municipal government and nonprofit environments. And as I started to think about all of the things I did in the past, I realized that everything I've done has a focus on thinking about how to better help people, whether individually or in communities. And as I got older, I realized that I really am a people person and that I thrive in sorts of positions where I can consider how to meet individuals and communities' unique needs. Some people might call this community or economic development. That's what my bosses called it in the past. But at the end of the day, it still focuses on people, on humans. And for this reason, throughout my class, I realized that I had a keen passion for better understanding human-centered design. While we were learning about usability evaluation methods throughout the semester, one thing I found myself really interested in was the many different techniques that existed, and how each of these techniques had been developed and refined as new user interfaces and interaction techniques came about. However, one day I was working on a virtual reality application with a group, and as we were thinking about how we might run our user tests and evaluate some of the interactions, I realized that all of the methods we'd reviewed in the past didn't really seem like a good fit for evaluating our product. And this made me a little bit worried. How could I possibly use some of these traditional and long-standing evaluation methods to evaluate my virtual reality and augmented reality applications? And so I decided to do this study because I thought that there was a gap in this research and I wanted to better understand, well, what research had been done specifically around virtual reality usability. I think this is really important. First of all, virtual reality is very different from traditional user interfaces, and the ways in which you're going to evaluate it need to be very different as well. And it's really an important issue for our time. Virtual reality is more widely available, and it's used for lots of different reasons, for different industries, for different domains, and it's really representative of all of these new human-computer interaction techniques and tools, technologies, and input-output devices that are coming out. Finally, there's a lot of players in this field who are competing, so we really need some new methods for evaluation. So the goals of this project were really to frame the robust and informative, yet, as I found during my research, really sort of dense and overlapping body of academic research into a more digestible roadmap that would help designers or developers or engineers or anyone else tasked with building and evaluating virtual reality applications to quickly and easily identify which evaluation method might best meet their needs, especially since most of these people aren't human-computer interaction experts, and they don't have ideas into the sort of unique technical requirements and issues that come about when using these types of technologies. So for the goals of this project, I really wanted to review the prevailing literature and see what's out there and what's been done, to define what virtual reality is and to see why is it uniquely different from traditional user interfaces like apps or a mouse, any sort of traditional input devices we currently use and output devices such as screens, projectors, anything like that. I wanted to sort of understand and categorize issues that I found that were specific to evaluating virtual reality versus other types of applications. And I wanted to identify some of the current evaluation methods that are out there and compare which might be the best. Since much of the earlier research really relies on evaluation tools and technology constraints at the time of the study, I also thought that current and emerging technologies such as wearables, facial and feature recognition, and more accessible and easy to use virtual reality and virtual environment creation tools like Google Cardboard and Unity, or distribution platforms such as the new technologies that are coming out, HTC Vive, Samsung Gear, again, Google Cardboard. I think that these new technologies have a lot of potential to support evaluation methods in new ways. So I also sketched out some of my brief ideas for how newer technologies might be used, and some related areas that I wanted to look into further and experiment with as I move throughout my program and my degree. However, the overall goal for this project at the end of the day is really to just build a more understandable framework that designers can use to select which evaluation method might be best for them to evaluate their virtual reality product. So the first thing I sought to do is to define, well, what is virtual reality? And at its heart, virtual reality is really a replication of a real environment, or as we call it, reality, which is the state of things as they actually exist, rather than as they may appear to be or might be imagined. And according to the book Understanding Virtual Reality, Interface Application and Design, there's 4 key elements that perpetuate virtual reality, which is a virtual world, interactivity with this virtual world, the feeling of immersion, or the feeling that you're in this virtual world instead of in your real reality coming from the senses of what you see and do in the real world, and also sensory feedback that pushes into this sense of immersion. So getting feedback from a virtual world that makes you feel like you are in that world. And virtual reality is also really unique. Experts assume that the role of these virtual environments, which is an instance of a virtual world presented in an interactive medium such as virtual reality, so the environment that you're in when you're using your virtual reality, they assume that the role of these virtual environments is to represent the real world as faithfully and naturally as possible. And while some of these virtual environments might be an unnatural world, such as a virtual information space or a sort of unnatural scalar point of view, like looking at the whole universe or looking at the surface of a molecule at this molecular level, virtual environments still need to conform to or purposefully reject our expectations of real reality, helping users build what we call a cognitive model of how they can experience and interact with the unnatural world that they're in as opposed to the real world around them. So a cognitive map of how they can walk around and interact with objects in this virtual world, roughly based on how they might move and perceive things in our own world as their basis for reality. Now, one of the biggest challenges with virtual reality is really defining it, however, because V stands for variety. There's a huge amount of variety in both the input and output devices and the applications of virtual reality. So here you can see just some of the different types of virtual realities there might be in terms of fully immersive, some of the different technologies and input-out devices we're using. And here you can also just see the wealth of ways in which we're interacting with this virtual world, whether it be haptic, a plain controller, or these sort of really complicated devices that map our tactile feelings into this world. And so as I went through and I looked at this, I first decided that we needed to roughly classify them by one of the most important sensorial interfaces, which is visual feedback. And by doing so, we can roughly define virtual reality into 3 buckets: into desktop virtual reality, such as 3D games like World of Warcraft or a Fallout 4, or any sort of thing that is viewed through a screen on your desktop. A head-mounted display, or an HMD, in which you're wearing some sort of virtual reality goggle that limits your line of sight into this virtual world, or also a cave, which stands actually for a cave automatic virtual environment. It's in its own name, and stands for a room in which the virtual reality is projected into the room around you, so you don't have to wear anything in order to be fully immersed in it visually. And we also need to think about the types of input that we're going to use. Given that virtual experience is so important, I also wanted to look at why is evaluating virtual reality different from evaluating traditional interaction methods. And the real big reason behind this is because of the virtual experience. Given these elements that we talked about before, the 4 key elements, which is a virtual world, immersion, sensory feedback, and interaction, combined with the variety of output input devices there are, it's really hard to evaluate virtual reality using these traditional usability methodologies. Their interaction styles are so radically different from an ordinary user interface that these well-proven methods that produce these usable results for graphic user interfaces may not be neither appropriate nor effective when trying to evaluate virtual reality interfaces. So, a traditional desktop system or a tablet or a phone graphic user interface is just radically different from the multiple types of technologies and interactions possible in virtual reality applications. But what are these differences exactly, and what do they look like? Well, The biggest difference, some of the biggest differences can be categorized like this. You have a real world environment and the technology that you're using to be put into this virtual world. For example, most head-mounted displays don't offer a see-through window into the real world, so evaluators need to make sure that people aren't going to knock anything over or trip over cables or move outside the range of recording equipment for performing usability evaluations. There's a lot of similar problems in cave environments where physical walls and obstructions can't be seen because of the projected visualizations, and again, you have people walking into things. Another big difference is presence and immersion, which aren't really important for traditional graphical user interfaces. So if you're physically observing a user's interactions, evaluators can risk breaking the user's sense of presence in this virtual world, which is something that a lot of virtual reality applications really care about. So if I'm sitting there recording with you with a camera or talking to you, you're being pulled out of this virtual world, and this can interrupt our usability evaluation. I also might risk interrupting you if I need to give you a new task or to ask you for feedback or to provide guidance if you're confused at some stage of the usability evaluation. Another big issue is users or user-related issues. A lot of VR is still being explored for the first time, and the applications of it are unknown and just being experimented with, especially across different industries and creative domains as we try to solve these problems and get users more engaged. So there's really no precedence for companies to identify, well, who are their ideal users? The target user populations aren't well defined. There's not experts in VR. We don't know who might necessarily be using this application from the get-go, and this can make it really hard for evaluators to generalize performance results across audiences. And also, since very few people can be considered using an expert in using virtual environments, except maybe the people creating it themselves, it's really hard to get a representative sample of both novice and expert users, since the development team is probably the only ones really familiar with the virtual reality, at least until it becomes more affordable and widespread among normal people. But perhaps the biggest and most significant difference that I find that's really interesting between virtual environments and traditional user interfaces is rooted in our perception of reality itself and these assumptions we make on what's possible in virtual realities. We expect that they kind of operate like the real world, and we can do things in this virtual reality that we can do in the real world. And this leads to a lot of problems, specifically around haptics, how our sense of touch and feeling, and the imperfection of these haptics when we need to navigate through these virtual worlds. So an example of this is if I'm touching something in a virtual world, I'm usually not going to feel that in my fingers, the touch of it. So we might need to map this to other senses, like playing an audio tone when something's clicked upon, or having it glow when I'm selecting it with my virtual hands. There's also some issues around user representation and presence. What does my avatar look like? How do I fit into this virtual world? Can I see myself? What is my sort of sense of embodiment in this virtual world? And finally, the graphics and reality. This is less of an issue now that render times are getting better and the technology is getting better, but it's been a big issue throughout time that our graphics can't faithfully represent the virtual reality to be as real as our own reality that we experience every day. And as you can see there, I think this is really the biggest issue and something worth further study. So how can we start to overcome this challenge? Well, there's been a lot of research undertaken examining if traditional usability evaluations can be utilized for virtual environments, and if they can't, what modifications do we need to make in order to address some of the challenges I mentioned earlier, stemming from these unique differences of virtual reality interactions. While a lot of studies have reviewed the efficacy and the results of these methods, I think it's more useful to understand when, where, and how these evaluation methods might be used. Later research, specifically that by Bowman, Gabbard, and Hicks in 2002, quote unquote later, start trying to solve this issue by reviewing and collating virtual environment evaluation methods to date, looking at different key characteristics they share, such as the involvement of users or representative users, the context of the evaluation, whether it's broadly defined or very specifically designed, and the types of evaluation results produced. So I think this can start to answer the question of how should we know which of these methods to use when. And so they built this classification framework that I feel is really useful moving forward. this study looking at these three categories for classifying virtual reality evaluation. And these three categories are there users or are there no users? What is the evaluation context? Is it specific or broad? And what sort of result is produced? Is it quantitative, more sort of storytelling, feedback from users, or is it quantitative? Is it hard numbers and statistics around tasks and time on task and completion of tasks? And by breaking it down into each of these three categories, you can start to identify for each of them how does it extend the traditional usability method present in that type of evaluation, whether it's like a heuristic evaluation or a formative evaluation. What are the positive aspects of using it, and also what are the negative aspects of using it? And so really quickly, I'm going to just pull up this classification framework that they developed, which I'll be talking about a little bit further in the presentation, as I think it's very useful for this type of work. So as you can see here, it has the evaluation type, and it starts to sort it by these key characteristics for which ones we should use. Does it involve users, yes or no? What kind of result does it produce, quantitative or qualitative? And what's the context of the evaluation? Is it generic or application specific? And it should be known that a performance model, according to the authors of the paper that looked at this, Bowman, Gabbard, and Hicks, a performance model in which there's no users that can be used for either generic or specific evaluation types and provides quantitative results has not yet actually been tested with virtual reality whatsoever, although all of the other types of evaluations in one form or another have been adapted and looked at by various researchers over the years. So I'm just going to go over two of these evaluation methods and looking at how they might be adapted for virtual reality. If you want to learn more about it, you can read through my paper, which goes through each of these and specifically talks about and breaks it down by these categories. Does it use users or not, the generic versus specific, and the type of result. And in the paper, I also look to think about what the unique differences virtual reality bring to it, and also how any newer technologies, since a lot of this research that was done pre-2010, so how does these new sorts of technologies we have now, both for recording user feedback and for recording and producing virtual reality, how can they bring a new level to make it better? And so for the first example, I'll just walk you through a formative evaluation. So a formative evaluation is basically when you have a sort of cognitive walkthrough or things like that which address interactions between a user and a graphical user interface. And it requires users. It's application specific. It can't be used generally across all different applications. And it can provide both qualitative and quantitative results depending on how you measure it. So you can either ask the user, well, what are you doing now? How are you thinking about it? Tell me, please speak out loud and talk to me. And we can also look at things like task completion, time on task, and measure those quantitatively. For virtual reality, so as I said, to empirically assess interaction techniques by iteratively placing users in a task-based scenario. So giving them a task, seeing how they complete it, asking them to talk out loud about how they're completing it, and then quantitatively measuring any metrics around the completion of this task. And for virtual reality, we need to think about how the tasks reflect new models for interaction, giving the unique elements of virtual environments. So in virtual reality, you have a lot of different things you don't need to do in traditional graphic user interfaces. For example, you might need to navigate and explore. You might need to do a task-based activity, or the system might take over and have control. And I found that the benefits for these sorts of evaluations in VR is that it's really effective even if users have no expertise. It requires no expertise on their behalf. And this is really nice because it gives us a much more representative sample of users, since we don't need to bring in experts and sort of compare and contrast how they're doing. However, it's also really challenging because it doesn't yet include diagnostic evaluations. The current model for looking at these formative evaluations is really informal and doesn't provide this sort of thorough examination of how we can look at the quantitative side of this and really map a lot of the issues that are going on. Another type of evaluation is a heuristic evaluation, in which several usability experts will separately evaluate an interface design by applying a set of guidelines they've come up with before, or heuristics. These were derived from Nielsen's heuristics, which were created in the 1990s, and they've been used for a ton of graphic user interfaces in the past. However, for virtual reality, we need to extend these, and we need to think about how we can have this direct mapping between systems in the real world. Okay, so how can we take these traditional guidelines of what makes a good graphical user interface and translate them to take into account this need for intuitive interaction and a sense of immersion? Again, two of the key elements of what makes good virtual reality. So some of these are going to have a direct mapping, so between the system and how the real world works, and some are going to have an indirect influence, such as consistency and standards across different types of virtual reality applications, which can also be difficult since so many of the technologies behind them, both the input and output devices and the uses of the virtuality themselves, aren't really defined across different guidelines. We have a ton of different hardware and software that we're trying to play with. So given the underlying assumption that the goal of virtual reality is to represent the real world as faithfully as possible, we need to think about how we're going to modify these already existing heuristics for virtual worlds. And there is actually a list that has been derived from Nielsen's heuristics created in the 90s that looks at this. So the benefits of this type of evaluation is that it doesn't need any users, so we don't need to go through for looking for them, and it can either be generic or application specific, and it's usually going to give us some qualitative results from these experts about how the interactions are and how the interface is. It's very quick to employ, and since there's this limited sense of principles, we can get a really high return on our investment for the cost put in. And we can actually tie these directly to design interventions that can be used by the team to make these actionable changes to the technology itself. It's also challenging, however, because there's a lot of different types of technology out there for virtual reality, and you can't uniformly apply the same heuristics to every type of virtual reality. It would be really irresponsible to try to apply a heuristic for, let's say, a desktop-based virtual reality in which you're navigating around with a mouse and keyboard for a head-mounted display-based virtual reality where you need to have the head moving with the actual field of view in the virtual reality, and you start to get into these issues of people getting sick and sorts of lag times with the video, making people feel disembodied. So we recommend, or the research recommends, doing a prior tech audit ahead of time to provide a limitation benchmark, which allows you to understand that yes, this is the goal of the heuristic. However, because of the technology we're using, there is a limitation, so we need to either rule it out or modify it and understand that it might not live up to the same standard because of the technological limitations of whatever the virtual reality is being used. At the end of the day, this might still be too generic since there's just so many different types of virtual reality, but as we start to have it come out more and more and we start to standardize some of the technologies around this, especially the input and output devices, it may get easier to define a really good list of heuristics that we can use for evaluating further virtual reality. So as I said earlier, I think there's a lot of new technology that can also support evaluation, and specific ones I want to go over are facial and feature recognition, which could help us record users' confusion or their engagement without losing the sense of presence by talking to them. We could also map these features onto avatars and just sort of look at the avatar itself. So if it's following the person's face, we can just look at the face of the avatar since it would be reflecting the person's face. Biometric feedback, which really nicely and discreetly helps us record quantitative indications of users' immersion and presence. So reactions to any virtual stimuli versus real-world stimuli. So if I had a dog growling and barking at you in virtual reality and your heart rate's going up, this might be an indication that you're actually immersed in the virtual reality itself. Finally, the very technology itself, just faster and wire-free physical technologies can start to help eliminate issues with physical spaces and immersion, tripping over things and any sort of safety issues, as well as sickness that comes from having a lag in your vision between the real world and the virtual world, and really limits the length of tests that can be done and how often these tests can happen for users. Throughout the paper, I found that there is some really interesting areas that we can also study further. First would be combined methodologies for evaluation. So is there any methodologies we can combine between the two? and sort of look in that way. And there's a lot of interesting research around sort of test bed approaches to virtual reality by combining, maybe heuristic and cognitive walkthroughs, or, different types. Also, looking at what method is best for which stage of the project. If we are, doing through discovery and ideation and putting the look and feel on later on, which evaluation method is best for which stage of the project that we're doing, whether it's at the beginning, the middle, at the end, since testing should take place throughout the entirety of your project cycle. And finally, developing better guidelines, heuristic guidelines or otherwise, as the virtual reality input and output devices become more standardized. We can already start to see that virtual reality is really moving towards head-mounted displays and sort of hand-based controllers that have buttons on them that can be pushed for certain things, but also map the user's hands in space in some way, whether through an accelerometer or a gyroscope or any of those sorts of things. So as these become more standardized, versus your HTC Vive, versus your Samsung Gear, versus your Oculus Rift, versus your Google Cardboard, as we start to move into one type of input and output device for virtual reality, it might really allow us to create better standards for heuristic evaluation, as we've been able to do with things like mobile phones or tablets, as the design of these, again, became standardized as time progresses. So I encourage you to read through the paper. I think it's a great read, and thank you so much for listening to this presentation. You can always see more of my work at danamartins.tech, and I am available to discuss this, to go through the paper, and also to give this presentation to designers, developers, and engineers. And I'm really looking forward to working with the tech community at large to start to think about some of the methodologies we could use to just have more usable, more immersive, and just really awesome virtual reality apps moving forward. Thank you.